потім. Так. Угу. Добре, ну небагато сьогодні людей під'єдналось. Якщо немає запитань, то тоді давайте сьогодні почнемо. Сьогодні у нас ми зробимо, принаймні спробуємо. Подивимось, чи вийде, спробуємо зробити запис того, що сьогодні буде. А сьогодні у нас буде трохи незвично. Сьогодні вам пропонується подивитись на зв'язку Spring і Mongo. Тобто ми зараз глянемо не на саму Java, а трошки зробимо відступ, щоб було цікавіше. Так, подумайте, чи є якісь у вас запитання. Якщо є, то краще питайте зараз. Якщо ні, то тоді будемо починати. І тоді вже питання під кінець, після. Так. Здається, немає запитань. Так? Давайте я тоді шарю екран. Сподіваюсь, що всі, хто бажали, вже під'єднались. Видно? Так, все. Тоді зараз починаємо запис. І we will switch into English.
Recording in progress.
Today we will take a look into Spring and Mongo. The plan is the next. First of all, we'll take a look into problem statement, which is not specifically related to the technology stack, but mostly can be solved by technology stack. By technology stack of Spring and Mongo. Next, we will take a look into the proposal solution, the solution that can help us to solve the problem. Then we're going to take a look into the examples. Most of the time we will spend specifically to the example. And at the end, we'll try to take a look into the quick demo, how it works. So, first of all, let's start from the problem statement. During the practical work, it is often a situation when it is required to implement some basic CRUD functionality to save some information in storage. Save it, update, get it back to the front end, and so on. Also, it is often a rare situation when it is required to change data model, to add some field, to rename some field, edit some field inside of the model. This is quite regular situation, and maybe you're noticing that this is part of the work that repeated. And what is the difference between one CRUD and another one CRUD? Specifically, there is not too much difference between them. The difference is in information. The difference is in the model that you are operated. This one is the difference between different CRUDs. So most of the time we just spend the time to do the same things, to write CRUD one more time, and so on. And also we spend some time to work with the models. And this kind of work, it takes some time, but to be honest, it's not too much intellectual. It doesn't require too much intellectual efforts to do this, but we have to do this. And the question that is raised here is it possible to automate this monotonous work? somehow. The reason why? Just because to do not do the same things each time. Do not implement CRUD each time. Do not working just only with changing the models. The answer is for this question, is it possible to automate this work, is if your technology stack consists of Spring and Mongo, then most probably then the answer will be yes, it is possible to do. This is a short answer. Let's go a little bit more deeply into the details. Why, if we are using Spring and Mongo, then we can automate this. First of all, let's take a look to the Mongo. What is the Mongo? Mongo, it is NoSQL database which saves information in a format that is similar to JSON document format. If we'll open the Mongo, take a look into the information, we will noticing that it stores like a JSON document. There is a class from the org.bson document that is a representation of Mongo document, and it represents this information, this document, as a map with a key and value. So we have representation of JSON as a map with some keys and values. But we can work with different keys and different values. So it means we can store different maps. Not different maps, but different body of the map. So it means we can store and we can get different objects from the Mongo without strict structure. Also, Spring contains method to work with this instance of class org.bson document. So we have methods to work. So we have functionality, we have ability to save whatever we want into the Mongo, any structure. We don't need any specific model. We can create the map, put inside the map whatever we want, and save it. In this case, the next question is arised: why not provide the opportunity to work with non-strict data model on API level? If it's possible on the persistence level, where we can store in Mongo whatever we want, why cannot we do the same thing using the API level? Yes, there is one tricky moment that if we will provide access to the document on the API level, then we will build the dependency to the persistence level. So we will depend it on Mongo. But sometimes maybe it makes sense, because if you are sure that your database will not be changed, then instead of writing a huge number of functionality of CRUDs, maybe it's just better to get access to document on the API level. Also, we should think and we should keep in mind that and consider the possibility of saving document on the same type in the single Mongo collection. What it means? Okay, if we can put whatever we want in any place in Mongo, in any collection, then it will create some mess inside of single collection. So it will contain different objects with different structures, which is not so good. So if we will be able to save similar instances in same collection, it will be better, but we have to be able to save any kind of structure. And now it's time to look at example in IntelliJ IDEA, and then we'll take a look into some demo. But first of all, let's start from scratch, and it will be first even more clear. Maybe some of you didn't do this before, and it will give you opportunity to implement the same things. So what I'm talking about is if we want to create the project, if we're talking about Spring Boot, then most probably the first place we're trying to go is the Spring Initializer. Let's take a look for Spring Initializer. Here it is. So this is the site which name start Spring IO. Here you can get the basic structure of project, like a starting point from which you can start work with the Spring Boot. So how it works? Here we should choose what we kind of parameters we want to work with. So for example, the project. Okay, let's say we will choose Gradle Groovy, language Java, Spring Boot. We can choose the latest version 3.2. Project metadata, I guess we will change it. And packaging, let it be jar, and Java, we will use the latest one, 21. So about the group name, mostly it should be reverse name of domain name, of company name. So we don't represent now any company. We'll just put here subdomain to make it more clear. Artifact, let's name it as a CRUD. So it is the name of our service, how it will names. The packaging automatically change, and it looks not so bad. So it's reverse name of company should be, so for domain name of company. Then the project which we are working on, CRUD, let it be. Here we can type, instead of demo project of Spring Boot, let's name it CRUD project for Spring Boot and Mongo, something like this. Then on the right side, we can also add some dependencies, what we will need. And all of these dependencies will be automatically inserted into the builder. In our case, we're talking about the Gradle. We can click the button and choose what we want. So we're talking about the Mongo. So for the Mongo, we have two options here. It's reactive MongoDB and Spring Data MongoDB. Spring Data reactive MongoDB and regular one. We have to choose this one, regular one. It is kind of implementation of Spring Data, which is related specifically to MongoDB. There is different kind of implementation of Spring Data GPA, Spring Data MongoDB, and so on and so on for different kind of technologies. Most of them contain some interfaces as repository interfaces under the hood, which is the implementation of basic CRUD functionality. The difference between both of them is that this one is used for reactive approach, and it will return the instance of flags and mono, which will tell us that this information will be returned even if the execution is not finished yet, but we will already receive something from database. So we'll go for now in more traditional way in this one. Then we can choose another one. For example, validation, let's add it. Web, we're gonna implement some controllers, and I would say Lombok also is good for us. It will be enough. Most of the time I also add some actuator and maybe additional, but I think in our case it will be enough. We can click the button generate, and the zip file will be saved, will be downloaded. When you will unzip this file, when you will open it in IntelliJ IDEA, then you will have the base structure of the project. I already add some code here, and let's take a look at how it will look as a result. Just 1 second. Now you have to see the screen. So when you will open the project, you will not have such packages. We will take a look just a few minutes later. But firstly, you will have build Gradle file. It will look in this way. You will have version. Then, for example, first of all, plugins. In our case, we have Spring Boot 3.2. Java 21, configuration, repository, version. By default, you will see here 001 snapshot version. I put all versions for this in specific file, which is named Gradle properties. It is quite useful, so you can do in a similar way. Then dependencies, you can see here that it was added Spring Boot starter, data MongoDB, validation, web, Lombok, and even test, everything that we ask it for. And also we can add 2 additional dependencies. For jars, it's model mapper, quite useful thing that give you opportunity to transfer one instance into the another one automatically, like auto mapper between 2 instances. And another one is Swagger, which is mostly used for description of API endpoints. Then you will have also application properties. It will be by default empty. We can use 2 options here. The first one, we can change the default port to something else. In my case, it will be this one. By default, it will be 8080. And we have to put the path to Mongo. So for it's only one configuration that is enough. No need to create any classes with annotation configuration and so on. Spring Boot by default have a lot of things. Just you can use it. And for MongoDB to connect, we have to put the link to the Mongo. Yeah, by the way, I think we can go to Mongo and take a look how it looks right now. Why not? Just one moment, please. I believe you have to see the MongoDB. If you don't see it, please let me know. So for now, we will have the database CRUD, and let's say we will have single collection model and nothing else. So now it's just empty. Let's go back to our service. That's what you will, yeah, and you will have CRUD application, which will be added by default. No packages will be inside. Everything else should be created manually. The structure, it can be different. It depends from personal opinion, from personal wishes, from some knowledge, and so on. I personally, since different kind of structures, came to the next one. For me, it most understandable, and let me try to explain. So I have 3 main packages: persistence, service, and web. And they represent as 3-layer architecture. The first one layer is persistence to communicate with the storage. The second one is layer of business logic, and the third one is a layer of presentation. And we have additional package utility, which is not specifically one of the layers. So inside of persistence, I usually put such thing as interfaces, then packages of implementation of these interfaces, entities, and specifically for the technology, if we're talking about Spring Data, this is repositories. Sometimes you can see that package entities can be put it outside of persistence on the top level of project. Why not? It can be. Some of the developers do this. Sometimes you can see that these interfaces or implementations are also on top level in different packages. For me, it's better to understand when it's inside of one persistence layer. Why? Because from the business perspective, when I will write the business logic, I will know, I will just communicate with interfaces from data access. I will not know about the implementation, which kind of implementation we have under these interfaces. For now, we use Spring Data MongoDB, but it can be Spring GDBC. It can be then what? Then additional package will be created with another implementation, but interfaces will not be changed. It can be Spring Hibernate, Spring MyBatis, whatever. It will be just different packages with different implementations, but the structure of interfaces will not be changed, and you will be still able to get access and do your things from business layer. Entities is also is about storage. That's why I put it inside of persistence. Repositories is just specifically for the technology. If we will use not Spring Data GPA, but Spring GPA, there is no repositories. There is entity manager, no need of any interfaces. So this is technology dependent things. That's why I also put it inside. The naming, maybe you can noticing that there is an I at the beginning. It's more in traditional way. Nowadays, you can see that IntelliJ IDEA shows you the I that say for you that this is interface, but in the time when it was NetBeans, Eclipse, and there was no any IntelliJ IDEA and so on. There was not any symbols which can describe what it is inside. Is it interface? Is it enum? Is it class? And there was convention of naming to name it since I. Nowadays, with the Spring, with this IntelliJ IDEA and so on, in most time developers they don't use I. I still like an old style man. I keep it as an I, but for Spring, in most of the implementation, you can face with the naming impl without I, but like implementation. If we are talking about the Spring, I just combine traditional things and Spring. If we are talking about Java Enterprise Edition, instead of interfaces, you will see the naming as facade, something like this, local facade, remote facade. So it depends. We will have entities, just only one, and one implementation of repository. Let's go step by step. First of all, we'll take a look into general structure, then into the entities, point to the problem, and how can we solve. So, service. Service will contain classes with a business logic. This is the heart of application. Here is some business logic of what we will do. There is additional package with exceptions. There are a lot of them, but it doesn't make sense to go deeply. There is implementation of converter, which is based on model converter. We will see how it works on business logic. There is no interfaces. Also, some of the developers, they prefer to put interfaces for the service layer. I don't see any reason to do this because there was no chance that the business logic will be significantly changed. So, and these interfaces, in most of the time, you just put some method because they exist. But if you will compare for the persistence layer, where the technology stack can be changed, the business logic most of the time doesn't change. So, as for me, there is no sense to create interfaces for the service layer, but there is sense to create for the data access layer. Also, I'd like to point that if we use the repositories, sometimes you can see these repositories inside of the service layer. It can be, why not? It's not a mistake, but you will have dependency on this technology. And it means if you will change this technology to, let's say, another one, Spring GDBC, then you have to make some correction on the service layer. But if we will wrap it as under the DAO layer, then you will not touch service. You will just switch from one implementation to another one. That's all. Web. Inside of the web, I put most of the time controllers. Maybe we can, some of the developers create the folder package controller and put everything here. I prefer to use in this way because it can be REST controllers, as in our case, it can be regular controllers, it can be handlers. All of them is related to the presentation layer. So that's why I'll let it be here. There is global exception handler and DTOS, data transfer objects, or you can name it as a models object that will transfer information from front end to backend. Let's take a look for the entity. So we have one entity. there is Lombok annotation with no arc constructor, all arc constructor, data builder document, ID, and so on. ID, model, collection. So we have some fields. We have the magic instance of document or based on document. We will talk about it a little bit later, but this is a map actually. I want to switch your attention for the next one. Look, we have the structure. We have entities, we have data access layer, we have service layer for data model service, we have controller, data model controller, and so on. We have create CRUD for this model. Create, read, update, delete. Let's say that you got the new request. You need to save something into your storage, into your Mongo. Then you will implement another one controller, another one service, another one data, another one repository and entity, and you will save another kind of information. Then another one kind of information, and so on and so on. So everything will be quite similar. What will be the difference? What you are saving, this is the difference. Or let's say you have the data structure and you need to add some field. Then you will go here and add some field to the entities and add some field to the DTO instances, or remove or rename or something like this. Does it make sense? So it's regular things to do, but is there any way to create one CRUD that will cover all cases, any model, which will not depend to the model? As you can see, we have document implementation, but we don't have entities. We don't have repositories for the document. How it works? So first of all, let's take a look for the data model and then compare with the document. So if we will take a look to the data model implementation, this is a data access object class, which implements a data model. It contains annotation repository. Put it always on class, not use this annotation under the interfaces. It will work, but it will be mistake if you will put annotation under the interface. It will not bring you the value. Transaction annotation, actually, it's not required on this level. We can even skip it because we will use it on a service layer, and service will wrap by transaction different accesses to the data layer. So all of them will be under one transaction. And to implement all of this method, like find by model, find by ID, save, delete, exist by model, and so on, we use the repository interface. The repository interface looks like in this way. We extend from Mongo repository, parameterize it by data model, which contains the basic implementation of method like save, insert, delete, find by. We add specific implementation with find by model, exist by collection. As you can see, there is no query, so Spring will read this name and transfer it to the query automatically. No need to write something manually. So it will find by model and it will take as a model. It's similar if we'll take a look to the relational database, select from table data model where model equal to this parameter. So it will transfer to this query. We add 3 additional that is needed. And as you can see, most of this implementation is just wrapping the implementation from data model repository. You will not find implementation of this interface. It will be created by Spring automatically. No need of any developer's efforts for this. Does it make sense to write something like this? Yeah, maybe from this perspective, I also already mentioned you can use the repository immediately in service layer. But what if you will have another one implementation of this access? Let's say from entity manager. There will be different implementation. Spring Cabinet will be different one. So that's why I just prefer to keep it to make it structurized. So we work with this model and do the basic operation, like find by model, find by ID, save. But what if we how can we do this without strict model, without parameterizing by data model? To do this, we can use Mongo template, which give us ability to save any objects, and we can use the document. Instead of writing here data model, yes, we can, but we can use also object, any object, and we can use Mongo, and we can use document which extends from the map, which implements the map with a string and object. So this is a map actually. This is a map, and it's nice that this is a map. So we can put any map to save in any collection. We can save any collection. We can save any map in any collection, any structure. There is no strict structure. So using the Mongo template, we can save this document. We implement exist by ID. We create the query, just additional private method, which will create the instance of query, and by adding the criteria where ID is equal to this one. So first of all, we will check by query, which check by ID with a query by ID. Mongo template exists by query. Yeah, by the way, it's not clear what is the instance of this. It's not the good time to use var. I think it will be more readable in this case. Another one, modify document. So we also will get the query by ID, and we also remove ID from the document because we don't need to update it. We need just ID to, in case of modify, to find what we want to update. And we use the method find and modify. What is the difference between both of them? Save, it will, in case if ID is the same, it will update everything. If document doesn't contain one of the field, it will just erase. If we're talking about save and modify, we will find and modify, sorry. We will only modify field that is present inside of the document. All other fields will not be touched. They will not be erased. So we put here query. We will update by this instance, which we build based on this document. So if this instance will not contain some of the fields, then we will not touch it. Options, for example, return new true. You can choose another one option. There is so you can, for example, absurd option choose or some else, but it will return you previous value. If you want to get the updated value, then return new. What kind of instance we expect? We will say we will expect the document, not strict instance, but the map, which can be everything, and collection. Delete by ID, the logic is quite similar. Find by ID is also similar. We used the method find by ID, which is inside of Mongo template. There is additional method exist by collection, create collection, delete collection. Pay attention that exist collection and delete collection will not work if you have clustering MongoDB. In case of transaction, you have to disable transaction for working with collections. You can use annotation transaction, put as a parameter never. So in this case, it will work in a cluster situation. Find all field values. This is quite useful method with find distinct. We can collect all values of some specific field, and we will specify which field we are interested in. In our case, mostly it will be ID, but in some case it can be, for example, model, whatever we want, any field. We will collect all values from some field. Find all documents in practical, it's not so good to return everything which is in some collection, because it can be quite huge. Maybe it's better to use pagination or slice or something like this, but for demo purposes it will be enough. By the way, if you have any questions, you can ask, I guess, and then we will go forward. Okay, if you will have any questions, you can raise your hand and ask. Yeah, and we have a little bit more than 1 minute before the Zoom will drop it. And so They will be part number 2. Yeah, we take a look into the implementation. There is an interface, as you expect, I guess. So we have data model methods. We have declaration of methods of document. So this is 2 interfaces. This is repository, entity, and implementation. I guess we cover everything from data access layer, from the persistence layer, and we can move forward. We will take a look into them. Next, we will take a look into the service layer and the rest. So let's make, before Zoom drop us, let's make a pause and reconnect.
Recording stopped.
Давайте перезайдемо, поки Zoom не обірвав.
Перенесли тест. Це для обох груп, ну, першої і другої, ми там розподілилися.
Я думаю, що для обох, оскільки у вас згідно з розкладом жодної групи немає ніяких пар, тобто всі мають бути вільними, то буде краще, якщо ми проведемо для обох відразу.
Добре.
А тест завтра з якої теми буде?
Це буде по коду тест, це будуть оператори з позаминулої теми. Ви вже теоретично по цьому проходили, тобто арифметичні, бінарні, бітові оператори. Так.
Дякую.
Ну, таке питання там, от ви коли пояснювали, згадали такий термін транзакція, здається, але я не зустрічався з таким, що це таке?
Транзакція. Це, якщо коротко, це операція, яка має в собі характеристики, серед яких, наприклад, є атомарність. Атомарність – характеристика, яка каже, що дія або відбувається цілком, або не відбувається взагалі. І якщо вона не відбувається, тобто всі попередні піддії, вони відкочуються назад, відкочуються. Є різні типи транзакцій, але це окрема тематика, щоб не поглиблюватися. Ідея полягає в тому, що якщо ми виконуємо декілька дій, то, наприклад, збереження в різні таблиці бази даних, то якщо ми обертаємо в одну транзакцію, то перша дія збереження, вона насправді в таблиці ще дані не з'являться. Після другої дії збереження також не з'являться. От якщо пройшла перша, друга операція, і тоді транзакція завершується, якщо ми обгорнули ці всі операції в одну транзакцію, то тоді відразу з'являється все в всіх таблицях. А якщо, наприклад, у вас пішла ситуація, ви написали якусь інформацію в одну таблицю, а потім під час другої операції у вас виникла помилка, то у вас запис з першої, він відкотиться назад і він там не відбудеться. Тобто всі дії або відбуваються разом, або не відбуваються. Вони атомарні, як атомарна дія. Ну, якщо коротко, так, про транзакції.
Дякую.
Це для того, щоб забезпечити цілісність даних. Щоб не виникло ситуації, коли у вас в одну таблицю записалось, в іншій щось пішло не так, якась помилка, потім у вас розрив даних, десь щось є, десь немає, і все. Так, якщо є питання, питайте, якщо ні, то тоді продовжимо. Давайте тоді продовжимо.
Recording in progress.
Let's continue with example with communication between Spring and Mongo and, let's say, universal create, read, update, delete operation. So we stopped on the persistence layer, and we're going to continue with service and web. First of all, let's take a look into the document service, then to the controllers, and we'll take a look into the models and validator a little bit later. So we have logic inside of the document service. We have connections to and dependencies to data access layer of document. We have dependency to the model. We have dependency to validator, additional service. We have some cache. I will come back to this with more details. For now, just let's skip it. So we have it, but keep in mind, we have implementation of methods like find document, create document, update document, patch document, delete document. Most of these methods, just briefly, let's take a look for the general logic, and then we will go to the details. They accept as a parameters model and document ID, model document ID. Why they accept model, we'll come back to it also a little bit later. Most important that it accept, for example, document, and we will using the DAO, we will execute the method say document and save the document somewhere in some collection. And this is the answer why we use the model. We will save here in some collection. We will save map, and we can specify in where we want to save. Let's say you implement CRUD for one model, for one collection, but you want to implement it for another one model. Then another one model, most probably you will save in another collection. So somewhere we have to save information, which kind of structure, which kind of model we will save in which collection. That is why we have the instance of data model and we have the parameter model. Now let's come back one more time to the entities to explain. So for the data model, we have strict structure as we have some ID, we have the model. It will be like ID actually, this kind of parameters. We will work just only with this model. It will be for us much more clear and readable if we have just only one single parameter that it will explain and give us information, for example, like which kind of collection we should use. Yeah, we can extend it for future, but for now it's enough. And also we have the document, and this is the map, and we can put here whatever we want, any structure, and we will use the structure to compare, is it possible to save some of the document for this collection or not? Can we use it or not? So this is like the model with which we will compare all other documents. If they have the same structure, then we will work with them. If they don't have the same structure, then we will reject this kind of request. Now let's come back to the document service. So using this parameter, we will find the configuration. It's actually the configuration, the instance of a data model. From this data model, we will take the name of the collection, and also we will get the document just to compare our document with the document which we expected. If they have some difference, we will reject such request. If they are acceptable, if the fields is the same, then we can save it. Yeah, we'll go here. Just let's continue with overview of all of the methods. So we have update. It looks in the same kind of. We get the model. Then we validate that we can accept such a request. We get the existing document. We update the field. We save it and return. The same thing for the patch. Get the model, validate, get exist, update, modify document, which will modify just only some of the fields, not all of them, and return. Delete, we check that this is exists by ID. If it's not exist, we throw the exception. Otherwise, we will just delete it from the database. It's just simple logic. Now let's go a little bit more into the details. A little bit more into the details. So before we'll deep into the cache, what we have here inside of the model. So we have the model, find model by model. So what is it? It is a private method which will use the data access layer from data model. It will find this instance of data model. Otherwise, we will throw the exception that we cannot find it. This method is used in most of the methods. So we get the model, find it, and return. Yeah, we can say a few words about the cache also. So the cache is, it's not the best implementation of the cache because, yes, you can have several pods of your services, then the cache will be different one. But the implementation is that as a final result, in each pod, you will have the same values. Because what? Let's take a look. So first of all, we try to get value from the cache. If it exists, we will get it and return. If it's not exist in the cache, then we will go to the database, check is it exist in the database. If it's not exist, then we will put it to the cache. The simplest implementation, it can looks like we can use the method put, but we have map of the map. We have map which will wrap the model. So we will have for different models, different caches. And inside we have linked hash map, which will save ID and the document itself. So it is done just to do not go to the database and return information more quickly than going to the database. That's why regular put is not, we cannot use, because we'll then we will need additional actions with this linked hash map. The shortest way is to use the method compute. We'll specify here the main key, and then we'll have key and value here. And the value, as you can see, there is a linked hash map. So we will put linked hash map and our document which we want to put into this hash map to the method put document to map. To be short, we will create the copy to just to do not touch the exist document because it is mutable object. Then we will get ID. We will remove ID from the document. We will not need this into the cache as an object. We need ID just as a key. We will make some checking. Is this in what kind of ID we have? Is it a document? Because it can be as a map. It can be object ID, whatever it can be. Anyway, we will transfer it to string and use it as a key in our cache. Also, we have to check is if this linked hash map is null, then we have to, first of all, we have to create, otherwise we will use the exist one hash map. So this is a few words about the cache. And yeah, this is a method create. We'll also check the by ID. If it exists, then we cannot use this. We have to change ID. If it's not exist, we will create the ID. We will put the value to the cache. Update is quite similar logic. The interesting thing is that remove document is after the validation. So we will also validate ID, the structure of ID. If the ID is the JSON with some fields, then we will compare all of these fields. The logic is quite similar for update. The validation, yeah, we'll go to the validation, patch with a different validation, and delete. Yeah, also we have some additional methods like converting object ID to string. They are not needed if ID is in map, but if it is object ID, then we have to transfer it to string, because otherwise to the front we will return the instance of object ID, which contains timestamp and so on, which is not readable. Let's go deeply to validation and quickly take a look for them. So here we have two methods to validate. The idea is that we have two maps and we need to compare, does one map fit the structure of another one map? And to do this, we can, one of the possible ways to use the method retain. So we will create the new one linked hash map from which will contains only the keys, linked hash set, sorry. Then use this method, and if it will return intersection of these two sets. If they are equal, then no problem. But if they are not equals, then it means some of the element is not exist in one map, but exist in another one. So in this case, we are already ready to throw the exception, but we need to specify which exactly keys are different. To do this, we can, one of the ways, we can use the method remove all from both of them, and then these two sets will show us which case is not present, but they have to be present, or vice versa. They exist, but they should not be. Yeah, such thing can be implemented even here, but we need intersection set to go in the loop. What this loop is about: if the keys on the top level is equal, it doesn't say you nothing about the structures. If you have the values as a JSON with also some object with the keys, then we have to check all of them. So we go through all keys, take their values, then we take, see that if both of them is instances of map, then we just repeat this procedure as a recursion until we will finish. If they have different kind of classes, so for one of them, let's say string, but another one is object or JSON, then we can immediately throw the exception. The same things we have here. The difference is that for the patch method, we can use, it accepts less number of keys. It shouldn't be exactly the same. That's why we use here remove. Well, I think it's enough for them. Let's take a look for them controllers. So this is a regular REST controller with request mapping. There is a reference to our service. We have method get, post, put, patch, delete, which is what is something unusual is that, for example, for get method, we can see here the body, which it shouldn't be, but this is the ID, and the ID can be different. ID, it can be even another one JSON with some fields, another objects. So that's why it's better to put it as a body, not as a string. If we will compare for data model controller, here you can see more traditional ways where for the get method you can find just only pass variable, and request body is present on post method. Post method, put method, patch, delete, and so on. I believe it's time to see some demo how it works. For the data model service, just let's quickly take a look. Here is implementation, which will get the models using our data access object. We will also manage things with ID, with type of ID by this line of code, and using the DTO converter, we'll convert our data model into the data model response. Also, converter is used in create and vice versa when we want from the request get the data model. Then we create collection, save this information into the model, and return. Update also do the same things, and delete will also delete the collection and delete the instance. Nothing complex here. Let's try to run it. It takes some time. IntelliJ IDEA was not expected that this code will be executed. So we're ready. It starts quite fast. Now we can switch to Postman. Just 1 second. I believe you have to see my screen. So we have two CRUDs. First one is about the model. Let's double check it. Yeah, it returned nothing. Find all models. Let's create the model. So we will create some model, and based on this model, we will check the structure of all other instances that we will create through this CRUD. So we have model. Let's name it as local, collection local, which does not exist, and then document. And here we'll create the sum structure of the document. Let's say we will have ID which will be the complex one. If we will not mention here ID, then it will be created automatically with as an object ID. But for now, let's create the more complex structure. Then we have some key value, and for this key, we will have such instance, like within inner fields. Okay, let's do this. Done. We can take a look. Do we have any models? Yes, we have local. We can take a look, find model by name, by local. Here it is. So we created, we have endpoint find by ID. We can modify. The values doesn't make any sense, so you can put here whatever you want. What is makes sense, the type of these values, not the values itself. So we update it. There is a method patch, which gives you opportunity to update just only things that you want. Let's say I want to update just only these two kind of keys, and delete. I will not execute delete right now. So we create some model, and we're going to use this model when we will work with the CRUD. Now we have another one in points to work with the CRUD. And first of all, let's execute find all IDs. Do we have something? No, we don't. So we're going to create the instance of with this structure. Let me one more time show you find by model. So as you can see, we have such document, and we're going to create the similar here based on what we create in the model. If we will try to put here something different, let's say we will put here additional field in our object, and I will disable this one. Then validator should tell you that you are trying to use CRUD with a structure which is not eligible. Yeah, and we use as a parameter local here, just to specify where we want to save something. Let's execute it, and we see the message that model expected K2, unsupported K4. Okay, let's remove K4. Execute one more time. It says that K2 is expected. Okay, let's enable K2. Here it is. So we created. Let's call find all IDs. We have such ID. If we will execute endpoint find by ID, we can specify it here. And we got the result, find by ID. There is a method for update. For example, they also check the structure of subfields. So if you will put here something which is not acceptable, it should also let you know about it. Something like this, that this field is not acceptable. What does it mean? Let's make some conclusion. So we create CRUD. And let's take a look to the database. Let's update it. So here it is, collection is created, and we have the instance here. So using this CRUD, we can create as much object as we can, as we wish. It also check ID, that ID should be unique. All functionality of basic CRUD things. So you have CRUD that can work with different collection with different structures. We create such instance for this collection, but using API, we can create another one collection which will support another one structures, another one, and another one. As a result, no need to disturb the developer for the next time. No need to create the task for the developer to create new CRUD, to create or make some changes on data model. Everything can be done through API if it will be required. So one CRUD for different purposes, for different structures, different cases. Do you have any questions? Okay, let's Stop the recording.
Recording stopped.
Так. Можливо, якщо без запису у вас є якісь запитання, то можете питати.
Ну, може, не по темі, а в нас ще будуть якісь практичні.
Практичні будуть не для всіх. Тобто будуть додаткові практичні для тих, хто активно приймає участь, кого я пам'ятаю, от Антона гарно пам'ятаю, Юрія пам'ятаю, що активно під час семестру всі працюють. От для тих, хто активно працює, будуть додаткові за бажанням. Тобто обов'язково вже не буде, а будуть додаткові роботи, але не для всіх, а для тих, хто активно протягом семестру працює.
Угу, це зрозуміло. А я теж
Обов'язкових
хочу
не буде, будуть
додатково
тести.
практично.
М?
Я теж хочу додатково практично. Що до цього
Добре, ну ви
потрібно
сьогодні
робити?
просто активно приймайте участь на лекціях, приходьте, щось, щоб було помітно, що ви вчитесь. І все, цього буде достатньо.
Так, я зрозумів. Але
Ще раз.
що?
Буду виставляти там вже в папці, поки їх там ще немає, але будуть з'являтись. Ще поки час є. Так що, але вони будуть такі більш цікавіші роботи. А
Супер.
загалом для загальної, для всіх це будуть тести, оскільки у вас загальна кількість все-таки велика і покрити все практичними. Тести більш ефективні для великої кількості студентів, вони відразу покривають велику кількість людей. Тому тести в нас будуть, а практичні будуть вже для бажаючих.
Супер.
Так. Можливо, ще якісь запитання. Яка ваша взагалі думка з цього приводу, з цього краду, то, що ми сьогодні розбирали? Що ви вважаєте? Як і є, кажіть. Да. А что означает синхронно? Как может быть несинхронно? Будет работать так же, как работает любой крад. То есть транзакции на уровне сервиса. Если они пересекаться не будут, то есть идет запрос, и транзакции обеспечивают и их пересечение. Если это на уровне контейнера, и если каким-то магическим чудом на наносекундах оно совпало, то тогда один запрос подождет окончания другого, пока другая транзакция не закончится. Но это все настолько быстро, что незаметно будет. Та же самая будет ситуация, как с любым крадом, то есть со стандартным, даже вот вне зависимости. Если идет запрос, у вас, во-первых, сколько контейнеров сервлета, давайте с самого начала начнем, создается. По умолчанию контейнер создаст один контейнер, один инстанс сервлета, то есть он будет принимать все запросы. Это по умолчанию. Если потом скоп по уровням сервиса посмотрим. У нас там сколько бинов будет создаваться. По умолчанию в Spring идет синглтон, то есть один инстанс. Один инстанс, который создается контейнером, который обрабатывает все запросы. Значит, и так по уровню и presentation, и сервиса. Дальше смотрим. Значит, получается, запрос один идет, второй. Если на уровне доступа к базе данных, тут уже дальше смотрим на уровне базы и персистенции базы. поддерживает ли база несколько транзакций одновременно? По-моему, Mongo тут сможет поддерживать. То есть даже, например, если у нас один инстанс обратился к Mongo, Mongo у нас теперь зависит от Mongo. Если Mongo у нас отдается экземпляр моментально и может поддерживать другую транзакцию, то тогда ждать никто не будет. Если же до уровня Mongo у нас Mongo обрабатывает запрос, но не может параллельно взять другой, в другой транзакции, хотя инстанс у нас один и тот же, то тогда будет ждать. Но это уже на уровне базы поддерживается. То есть мы, как программисты, мы тут уже, наверное, бессильны. Если мы сделаем... Ну, во-первых, Mongo, ну, запросы... А в чем разница? Мы тут, вот, например, Mongo темплейте, смотрите, в Mongo темплейте... Да, в таком случае, да. Если просто thread sleep и один поток, конечно. Насколько я знаю, как раз позволяет. То есть было бы, если бы один запрос и потом все запросы ждали, то это бы, ну куда это годится? Никто бы не работал с Mongo. Конечно, оно должно позволять, еще один запрос не закончил выполнение, идет другой запрос. Но не забываем про контейнер. То есть main мы пишем, например, main это application контейнер. А если мы пишем там, ну, условно, там Spring, это уже веб-контейнер. Или просто на веб-контейнере веб создаем. То есть это контейнер уже менеджер создания бинов. И сколько он уже запросов будет принимать, это уже другой момент. Да, если вы просто main напишите, то это уже application контейнер, там один поток, и вы как бы все вручную делаете, там через вас все идет. А если на уровне контейнер, то он все запросы принимает, и он уже начинает вот эти моменты все решать. То есть он взял все запросы, и он их параллельно ведет. Сам контейнер. И сам контейнер уже отправит в базу несколько запросов. Единственное, что если вот он отправляет, а именно вот в рамках этой транзакции, именно эта запись с этим ID-шком еще занята, тогда да, он будет ждать, пока то не закончится. Но если у вас там другая таблица, другая ID-шка, то проблем никаких нет, которые не относятся к этой транзакции. Надо будет еще пример показать. Вот интересный, например, если мы сделаем сервис, а сервлет, там вот можно это хорошо прочувствовать. На веб-контейнер возьмем сервлет и будем параллельно, вот у нас несколько человек, это, кстати, надо будет попробовать сделать, параллельно отправлять запросы. И поставим, например, вернем в этом сервлете синхронизацию, сделаем синхронизed блок, и тогда вы увидите, что если вы быстро все будете нажимать там Enter на этот сайт или отправлять запросы, то будете друг другу блокировать, потому что есть синхронизированный блок. Вы как бы все запросы приостанавливаете. Если вы там синхронизed блок не будете ставить, то они все будут контейнером обрабатываться как в параллели. То есть не один за другим. Синхронизed блоки можно, кстати, помочь в этом разобраться. Да, да. Хорошо, можем рассмотреть. Это действительно тема интересная, полезная. Я подумаю, чтобы как-то запланировать это. Там тема на самом деле огромнейшая. Так. Можливо, ще якісь запитання є?
А, я там бачив анотацію builder на Entity. Я ось не бачив її до цього. Що вона робить?
Builder – це анотація, яка створює. Дивіться, ці всі анотації, builder, вони звідки беруться? Це все береться з бібліотеки, яка називається Lombok.
Ломбок,
Ця бібліотека, вона замість того, щоб писати вручну імплементацію, можна використати, написати анотацію, і під час компіляції ця бібліотека підставить вам реалізацію. Вже в коді буде реалізація білдера. Що це за реалізація білдера? Це клас, який містить методи по додаванню, по-перше, по реалізації шаблону білдера. А що це за реалізація? Це набір методів, який покроково може додавати вам одне чи інше, змінювати одне чи інше значення поля. Взагалі потрібно подивитися, що це за шаблон білдер. Білдер – це, на відміну від фабрики, абстрактної фабрики, от у вас була практична для всіх, це була на абстрактну фабрику. То на відміну від цього, це також породжуючий шаблон, який призваний створювати об'єкт, але відмінність його полягає в тому, що ми створюємо унікальний об'єкт. Тобто, якщо ми з фабрикою створюємо один чи багато інстансів, але всі вони однакові, то білдер – це спешл якийсь. Чому спешл? Чому унікальний? Тому що ви вказуєте, от в одному випадку ви можете додати одне поле, а в іншому випадку можете не додавати поле. Чи там додати третє, четверте. Тобто різні комбінації. Тобто, цим забезпечується унікальність. Тобто це в цьому випадку ця анотація builder, вона створює вам конструктор внутрішній inner, не конструктор, а внутрішній клас inner, який містить методи add, які в рамках цього класу ви можете викликати і додавати одне чи інше поле в цей екземпляр, конструюючи його під то, як ви хочете. Чи стало зрозуміліше?
Ну, так, в цілому я поняв, що він робить. Угу.
Це, якщо по-іншому, це ще от, замість того, щоб писати new, потім конструктор і в круглих кавичках вказувати всі параметри, ви можете з допомогою білдера, викликаючи методи там add, зазвичай, чи просто поле, якщо в реалізації ломбока вказуючи, через крапку перелічуєте методи і набиваєте ті значення, які вам потрібні. І все.
Угу.
Деколи так зручніше, ніж писати new і великий здоровий конструктор, де потрібно вказувати прямо всі поля. За допомогою білдера ви можете вказати тільки ті, які вам потрібні. Або це ще має сенс, щоб не робити там, наприклад, під різні поля, різні випадки конструкторів. Там 5 полів, 5 конструкторів, де в одному там одне поле, 2, 3, 4, 5, а достатньо там один білдер і конструювати так, як ви хочете.
Тоді,
Так.
якщо ми вказуємо builder, наприклад, то ми можемо не писати анотацію all are constructor, типу він вже буде builder.
Можна. Так. Ну там так, але якщо зручно, і мені, наприклад, я поєднюю і то на різні випадки. В одному випадку так, в іншому так. А можна і так, можна обмежитися тільки білдером.
Зрозумів. Добре, ну я ще почитаю зайду. Угу.
Так,
Все, дякую.
дивіться, у нас лишилось хвилина 30 до відключення Zoom. Я думаю, що вже немає сенсу після того, як Zoom відключиться, під'єднюватись. Якщо у вас є якісь запитання, питайте. Якщо ні, то будемо сьогодні на цьому, я думаю, достатньо буде. Будемо завершувати. По краду там щось зрозуміло було чи нічого не було зрозуміло? Що там, до чого, як?
Ну, щось, але не все, але ну, ще можна буде придивитися, я думаю. Щоб ще раз.
Добре. Там вже є одна запис, я от не знаю, якщо на англійській, на YouTube, якщо буде, напевно. Я ще подумаю, як тут. У нас 2 частини, напевно, будуть. Там вже є аналогічний запис на цьому. Правда, там на російській, але якщо хочете, вже можете в YouTube подивитися. Аналогічний.
А
Добре.
посилання
Посилання, там є, десь я скидував посилання в Телеграмі є канал, де скидую всі посилання на відео. Можна в чаті перемотати, а можу скинути просто в групу, де і все.
Ну, да,
Так, зручніше.
так, зручніше.
Добре.